Okay. I think it's working, and I did not label this live stream as a test, but uh, let's say I'm still learning. Yeah, I'm still learning. So there may be some hiccups. Okay, that'll work. There's a algorithm, part of an algorithm that I just don't like. No. Um, I got the algorithm from someone who is a far better programmer than I am. I'm not a programmer. And the person is a real mathematician. I'm not a mathematician. But and it's in Java. His version was in Java. Translated it, ported it into Python. But I just I hate I hate it. I just this part of the algorithm. Let me show you. Let me show you. Come on. Why is there so much lag? Maybe I need a new battery. Here. There it is. This part of the algorithm. I'm just never. I hate. I know. I don't like it. I don't. It doesn't look right. It doesn't feel right. Just it, from the very beginning, it felt. Um, Remember, I'm not a professional, so I don't have, I don't have a great description. But it literally felt uh, inefficient. I'm not competent enough to, in most cases, to look at the algorithm, to look at this code and say, oh, I see what the problem is. Blah, 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 blah. Like, I have no idea how to do that. I don't have that skill. So, um, that's why I'm saying it felt inefficient. Because that's seriously what happened. I did. I've had this for weeks or maybe months, and until, I don't know, yesterday, the best I could say was, the battery was dying. Okay, that's why the mouse was moving so slow. The best I could say was, God, this just feels wrong. That's the best that I could come up with. Yesterday, oh, and I tried multiple times to improve it. Oh my God, it's really sad. It's 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 kind of pathetic how many hours I've spent on this last section, this last half, just this part right here, trying to improve it because it's a lot, like 20 total hours over many different days, and everything I came up with that I was sure was better wasn't. Uh, it was it was pretty pathetic, and finally yesterday I was able to understand rationally what felt wrong about it, and it's the one of the things that feels wrong or that is wrong is that we're doing the same calculation every single time we get to this part of the loop, which is many, many, many times. Uh, oh God, how many times? I don't know. I calculated it. If I want to compute an undiscovered number with this algorithm, the loop would have to go about at least a billion, 1 billion times. That's not an exaggeration. That's an understatement. So that I don't come close to exaggerating. So we're doing the exact same frickin' computations every single time. It'd be a billion times. That's that. That doesn't make any sense. Finally, yesterday, when I was able to put my finger on it, I came up with an improvement. And it involves moving many of the computations outside the loop, just doing them once. What a concept! Oh. Yeah. So came up with that. No, this is still lagging a little bit. Crap. Oh, you can't see what I'm looking at. Not that anybody's watching, but there. Okay, that's sad. So the stuff that I was highlighting that you could not see, here. This is the section of code that's highlighted that I didn't like. And when I said I was just worked on the second half, that was, come on, where's my mouse? Now my mouse is real. Oh, come on. There we go. Why? 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 This is the part where we're redoing the computations over and over and over and over. And this is my prototype that I came up with yesterday. This lagging is really annoying. Um, to do the computations once before the loop starts and store the results. So what am I going to do about this? Why is it lagging? How am I connected? My Bluetooth? No. Why is it lagging? It's dirty. Why does that make that lag if it were dirty? No. I don't know what's going on. Alright, so I'm trying to improve it more. Come on. And I think I have identified. No, I have definitely. I can now articulate other things about the algorithm that I don't like, and I may have a solution for it. At least I can articulate it. This indexing system, even in this format, it requires too much work because the right hand side, this one, we're going in reverse, and that's just too much effort. It's a lot of extra computation to do that on every. This is a loop within a loop within a loop. To go in reverse so many times is a lot of extra work. So I think I figured out how to do the reverse computation just once, and then the indexing goes forward. And I think that will be better. And Lucas Andrade. Hello, Lucas. So that's so I have this is like a little scratch pad of working on the idea. Ah, hi, hi, Ilya. So now I think I'm ready to try and test it. And where will I test it? Seriously, why is my mouse so screwed up? CPU usage. Come on, man. This computation right here, that's a math folding computation in the background. How long has that been running? It's only been running for 48 hours. It feels like it's been longer than that. Um, if that were running at full speed, I think it would take 2 weeks. But I don't think it's running at full speed most of the time. So I think it's going to take a month. So I don't think it's going to finish because I'm pretty sure. The longest I've ever had a computation run is 14 days, I think, because there's power outages and blue screen of death and whatever. So, but now there's no lag. Okay, so is it something about uh, VS Code? Yeah, but 14 days is a long time, but it didn't even finish. It was this exact same problem. Uh, I've been trying to compute this same map for a long. Okay, I don't know what's going on. There we go. Uh, Theorem 2 trimmed. Right. I can't do it in Moomba yet, so I'm going to do it. Okay, so let's go over here and get the code that I made. Choose it indented. Yeah, something about VS Code, damn it. God damn it. There we go. Yes. That could help me out too. Okay. Length is state leaves total. Indices, make comparisons. Range. State leaves total length. List size pairs. Index mini gap. I don't want to use that. I don't want to use that. So what do I want to call it? Okay, good. Index for index in range. Good. Slice. Oh, yeah. Well, bon appetit, or whatever you might say in Dutch. I have no idea. Probably bon appetit, right? You guys are close enough to France. Praetor's question. Hello there. Praetor. Why do I know that word? Praetor. Praetor. No, I can't think of what it might mean. This is programming. Eat smakelijk. Eat well? What is smakelijk? Smaak. 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 What's the character's name from the series? Oh, okay. Sounds familiar. Can't remember why though. Slice. Slice. Leaves total length. Okay. That looks right. So now let's change that. So we'll make the two special arrays. Ah, well, at what age? Uh, well, I guess I do know how. I do know Python now, but it's been difficult to learn over the last 3 years. And how have I learned it? Um, ah, by banging my head against his desk a lot. I mean, the reality is, I learned it by just trying to build stuff and constantly asking LLMs for help and reading documentation. Ah, is it uh, for a programming language, no, it's not particularly hard there, but it could just it could be a lot easier if it would just not be computer science dorks. Too many weird abbreviations. What am I doing here? Make two special arrays. Okay. Leaf connectee. Here it is. Leaf comparison is the base array from which I will make two new arrays. This is my brilliant plan. Let's see if it works. Um, Indices make comparison. So this is state. How am I going to do this? Am I going to do... Okay, I don't care. I don't care right now. Dot leaf comparison. There you go. Thank you. And now, um, I have no suggestions for that. I haven't learned anything by watching YouTube videos. Um, uh, wow. If I were 16 and trying to learn programming, what would I do? I don't know. I started working with computers when I was 10, and I'm 50. So, um, and it was a very different environment for learning because there was no internet. So, um, I I learned well from documentation. Um, well, 50, not 60, but yeah. Well, I'm yeah. I I stopped. I quit the IT industry a long time ago. I was a lawyer. Um, so, okay. In general, um, uh, guided education or guided training is the best way to learn anything. Now, that might be um, uh, going to a school and taking a class. It could be a textbook, a book designed to train you. Um, and then online now, there's tons and tons and tons of options. Um, so if you're trying to learn something like Python for the sake of learning it, the approach is guided learning. Now, if you're really lucky, you get specialized guided learning. So, if you're taking a class, for example, and it doesn't have 600 students, it just has 20, 30, you're getting, and you can interact with the teacher, then you get the general guidance of the class, and then you can get the specific guidance from the teacher. So when you're having trouble with a particular area, you can go and ask questions and get guidance on it. That is um, the best way to learn a topic is okay. That's the best structure. I'll say motivation is really important, and things like exploration are hugely important. So um, I there's a poet. His name is Pablo Neruda, and maybe my memory is bad, but I swear I read a story about him that when he was like 20 years old, he decided that he wanted his profession to be poet, and so he told himself, well, if you want to be a poet, you have to write poetry, and resolves to write 5 new poems every day, which is insane. And well, he's in the Spanish language. He's he's I can't think of anybody who's a better poet than he is in Spanish. But I could be wrong about that because I'm not fluent in Spanish. But he's certainly excellent. So, but the main point of that story is if you want to be a poet, you have to write poetry. If you want to be a photographer, you got to take pictures. If you want to be a programmer, you got to program some stuff. And also, if you want to learn to program, just program. So, while the structured learning part is everything I said about structured learning or guided learning is true. All of that is true. It's also true at the same time that exploration on your own, self-motivated exploration, is really important. You're not going to learn to program if you don't actually program something. So whether or not you have a structured environment or uh, uh, guided instruction, the number one thing to do is to just do it. See what happens. And that's true for everything you want to learn how to do, or if you want to travel somewhere, or if you want to learn a habit, be somebody, be some be some type of person. You have to just try to do it. You might fail. You're going to fail a lot more often than you're going to succeed, in fact. But if you don't try it, you won't get there. You won't ever be able to succeed. I do not say you miss 100% of the shots you never take, because that's stupid and that's not true. because it doesn't take into that saying doesn't take into account opportunity costs. But it is true. Part of it's true. Um, yeah, there's it's a map. Let's see here. Come on, give me my mouse. So this is a mathematics website. 007822. This is the mathematics problem I'm working on, and here is the illustration. So if you have a map or a strip of stamps, I'm looking for a piece of paper. In how many different ways can you fold it? You can fold it like this, where it goes under. You can fold it like this, where it goes over. That's 3. So what this diagram shows, this is from a professional mathematician, I didn't make this, is not just ways to fold the map, but after the map is folded, it's symmetric. So that means that you can rotate it around some axis and it looks the same. So imagine rotating any of these diagrams 180 degrees, it still looks the same. So that's what the symmetry is in this case. Now these maps, how many different ways can you fold a map? The answers are crazy. For a strip of stamps, if you have a strip of stamps that's only, I don't know, let's look at real numbers here. Come on, give me a number. Go to yeah, I'm just gonna do this one because I'm more familiar with it. So imagine you have a map that has like 2 panels or a strip of stamps. There are 2 stamps across. If the if it's if your map only has 6 leaves total, so 2 panels by 3 panels, there's actually 8 different ways to fold it. And there's the here. And if you have, oh, excuse me, oh, a 2 by 3 map, just 2 leaves by 3 leaves, there's 60 different ways to fold it. And if you have a map, I don't know how often you've played with actual physical maps. If you have a map that's just 2 panels wide but 10 panels long, there's 9.4 million ways to fold it. So these numbers get really large really quickly. And so that's why we do it all in here. And these are mathematics questions. Like, nobody really cares how many different ways there are to fold a map. This is just mathematics. And the combinatorics, the mathematics of counting. And because the numbers get really large really quickly, it's easier to do it with computers. And so that's why I'm doing the symmetry check with the computer, because this one just one loop, I'm going to check, well, my, in my prototype code, I'm checking for 26 different possible symmetry uh, uh, arrangements. Let's see here if I've got here. So this is my proof to myself that's why it's duplicated. But I'm looking at like position A and position Y. Are they equal? Yeah. Yes or no? And then B and X. So this is one combination. This is a second combination, a third combination, a fourth combination. There's a lot. And on this particular map, whew, um, uh, I know this number. I've calculated it. How many? How many? I think it was 20. No, I don't remember. It's about 40 billion times. All right. Uh, uh, namaste. Thanks. Thanks, man. See, I'm going to. Oh, right. I'm going to use an array. Well, I, I'm doing that part. I hope it leads to something. You know what? I don't have to turn this into an array, do I? No, I don't. So I'm not going to. Okay. Okay. This is the part of the place I made. The arrays. No, I made Z. Okay. List. Prepare one element at a time. Slice. Where am I make slices? List, slice, pairs. I did. Okay, that's pretty good. This, 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 this. This here, indent, indent, indent. There we go. And for that, for that. This can't be this easy. I guess it is. Okay. I can ask I think it's right. Just, well, let's run it, see what happens. Not counting. 7 trimmed. Let's just go with 7. You gotta be kidding me. It worked in the first round? You gotta be kidding me. No way. Theorem 2 trimmed. Theorem 2 trimmed. 0.7222. I just, I mean, come on. Never worked for that first time. Just because I don't believe it. It's ready. Okay. Fascinating. Well, let's see how fast it is. I didn't do it before test. What do I got here? Yeah, I don't know. Do that. 1 second, 12 seconds. Why does that seem slower? I thought I had that down to 0.9. I swear I had it down to 0.9. Might be because we have double lookup here. No, but it only sliced it for indexing range. No, it sliced it more than once. Move the slice up. Duh. Okay, I can do that. I, I come on. What am I going to call this? It doesn't matter. This is the prototype. Sliced. Sliced. Left hand side equals There you go. There you go. Okay, that should be better because that's not going to slice it 10 times. Just going to slice it one time. Wrong button. Yeah, it's better. A little bit. Why is it still stuck? For indexing range, if slice is not equal to slice, then false break. Just making two new. Right. Right. That's in my notes. If this works, change this step so that I don't make an array that I don't use. Oh, that work? Indices make comparisons. Left hand side. Equal to yeah, look, this is a state. Leaves a total. Total plus one. Leaf connecting 0. So this fills leaf comparison from 0 up. Okay. Oh, it's not, I mean the size. I mean the size. Come on, think. Okay. 0. Yes. Yes. Plus not 1. Plus. Think. Leaves total plus 1. Oh, I don't know. If this works, that part works, this part will work. I just do this. Go to comparison. Comparison. Left hand side. Now I have right hand side. Left hand side and right hand side. Okay. Yeah. Right. 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 So, so first thing I do is take that off. Okay. Yes, that's true. Yeah, 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 yeah. Yes, thank you. That's exactly what I wanted to do. Now let's try it. Woo! Oh, look at that speed difference. Why is that so? Oh, because I'm not making the array multiple times. That's great. Jeez. Oh, that's great. It's like 16%. That's 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 fantastic. Um, so now I've got another trick. Come on, think. Comparisons. Right hand side. Indices, 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 make right hand side, leaf, connect D. Ooh, tricky. No, no, idiot. Don't do that. Plus equals fucking moron. Okay, and see if it works. Doesn't work. Okay. Why doesn't it work? Why doesn't that work? What is it? I don't know. But I don't know what I got to. Let's try this. Yes. Trying to what? Trying to build both arrays at the same time. Okay. So let's first clean out stuff I don't need this. Or that. And indices. This one only, I'm only using it for length right now, so let's change it. Here, here. See if I broke it. I did not break it. That's good. So that means I can get rid of this. This is great. I'll go slightly faster. Or not. Okay. Did it. Good. Okay. So where am I at? Trying to build the arrays at the same time. Which may not matter. I don't know. I don't know if it matters. Oh, 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 oh. That's I. I know why it didn't work because I didn't go in the right direction. Uh, tick, 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 tick. Right, right. No, well, that's not true. What? Why didn't it work? Why didn't it work? Because I put the wrong formula down here. That's why. Okay, I had the right formula here and the wrong formula there. Let's try again. Comparisons, right hand side. Indices, indices, leaf connectee. That part's correct. Now I need to do leaf connectee plus leaf total plus 1. Leaf connectee plus. Thank you. There. Does it work? Still doesn't work. Why doesn't that work? That seemed right. Right hand side, indices, leaf connectee. That's the same thing. It's the same thing. It's the same thing. I don't know. And I don't think it's going to give me a big improvement right now. Fuck it. 'Yeah, I can check how much time it takes. Um, Here, 21. let me do this one element at a time. So I think I should slice it. I should do like this. But maybe this is a better way to do it. It takes 5 seconds out of 110 to be created. I think a little bit of boost. Oh my goodness, slicing it is expensive. because the slices set to false. Slice, compare, hopefully it breaks at the first. Value comparison. I don't think this doesn't have an all. Well, let's see that. This, that. Oh, hey, it's faster. Look at that. That's great. Oh, that's great. That's great. Ow. Oh. Oh, sorry. Why does it work? Oh, because it doesn't exist. Okay. So why? No, they can't. That's okay. The slicing is still expensive, but it's all done in the same place. And it's actually less expensive now That's wild. It's like 18 seconds before. Okay. Well, this is a dramatic improvement using lists. So I can switch to arrays and get Numba to optimize it. Then it'll be a lot faster. How much does this cost? 5. That's 5%. God, that's a lot. That doesn't work. Maybe it's because creating a pointer, it's creating a view. That's not what I thought these were. Oh, right. These are right. First two-thirds is the normal array. Okay, so it seems the number one is overrepresented. Let's do that. Um, no, why do you keep saying bossy? You're going to sleep. I don't understand. Wow, there's a bunch of zeros. Why are there zeros? Why are there zeros? Why is the second half not working? The second set not working? This part is not working. Indices. Make comparisons. Right hand side. leave connect G plus date, leave total plus 1. Why is it not working? Why is it not working? Oh, because that's not necessarily the offset. Right, 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 right. Okay. This is the offset here because it starts at 0 and restarts at 0, but this one doesn't. This starts at leaves total minus 2. Oh my goodness. Okay, I'll figure this out. Let's see. So what do I want to look at? I want to look at indices and comparisons. I want to look at comparison left hand side, comparison right hand side. I want to look at the indices. Indices. This is what I want to look at. First, let's make sure that's right. Normal indices right hand side. What numbers? 25? 25. Oh, it's 25 that way. And it's 10 at a time. Okay, that's right. So, okay, so I want to look at the range. I want to look at that. Uh, I want to look at I want to look at this part, this part, this part. Look at that. Yeah, yeah. Here it is. 0 through leaf total plus 1, which is 25, and then starts over at 0. So, what does this do? Starts at a funky number. and think. Start to why it's still it's the the zero index of the left hand side corresponds with the 23 index on the right hand side. And this number 23 and this number 23 are the same distance apart. Why does it not work? We connect the why does it not work? Plus 1? Is it the plus 1? No. It has the, that's just it. Why is it not work? Come on, I can't see. Why is this not work? It doesn't make it. Oh, oh, okay. I don't have nothing. I don't have enough instance. I don't have enough instance. Okay. There's two different approaches. This repeats the indices. Indices make comparisons right hand side with repeats indices. So to get the zeroth value for the right-hand side, I go to index 23 on the left-hand side. And then again, way over here, uh, that's 26, 27, 28. To get index 28, to get index 28 for the right-hand side, I again go back to index 23 of the left-hand side. Okay, so if I want to make comparison right hand side at the same time, I need to use a slightly different indexing scheme. The first part is correct, would work. The part that starts at state leaves total minus 2. That part at a minimum would work. Track everything up to up to leaf connectee less than state leaf total plus 1. Right. Okay. Ah. So can I do state leaf total minus 2 plus 1? Without. Then this is just what them these terms need to be. I just do I take this out? Does that make sense? It's an offset. Yeah, I guess that makes sense. That makes sense. Offset. So those two numbers are the same. No, 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 no. Half right. half right. Back up. Just see, do the, boy, this one's really screwing my head. No, do that, X, this, yeah, it might be, well, I mean, that's a true statement, but there's nothing in there. Ah, okay. Go back to what I said before. I need a different indexing scheme. Um, different indexing scheme. So go back to here, and let's make a different indexing scheme. Let's make different indexing scheme. Indices. Indices. We'll just call it ZZ. We'll apologize. So yes, correct. This. There we go. Okay. And there we go. Different indexing scheme. This part is correct. Now, now, uh, oh shit. Okay. Okay. The value in the value. This is an index. This is not the. These are not the values. Look at this. This is an index. The value in zero. No. The index of zero should. Oh, you God, you uh, wow, this is breaking my head. Uh, wow. Now, there were zeros in here before, aren't there? I'm confused. No. Yep. But if Yes. What if is less than length? No. If T plus C equals. Right. Okay.